Oh, that was loud. That was a loud clap. Hi guys, and in this video you will learn about mirrors and lenses. Let's get started, shall we? Okay, so mirrors are the oldest optical instruments that reflect light, and you know, they were used by Egyptians a really long time ago. They're basically used by everybody now, and they could be anything. They could be polished metals, as long as you can see your image in them. There are mirrors. Like my phone could be a mirror because you can see an image. So my phone is a mirror, and there's 3 different types of mirrors. Okay, the 3 main ones, and they're plane mirrors, which are mirrors that reflect light at equal angles, and then there's concave mirrors, which reflect light from the inner surface, and there's convex mirrors who reflect light from the outer part of their surface. Okay, and I am really going to talk about plane mirrors and the equations that you would use for them, but I'm also going to kind of include some of like the other types of mirrors, and I'm going to tell you about the equations and how they work. So the equation for mirrors, this also can go with lenses too, is 1 over F equals 1 over di plus 1 over do. And do stands for the distance between the object and the mirror. Di is the distance between the image that was produced by the object in the mirror and the mirror itself. Okay? Ooh, okay, that's still loud. So the base equation, 1 over F equals 1 over di plus 1 over do, would be the base equation that you would use for mirrors. But you gotta remember that for mirrors, that if you're going to apply this to mirrors, that do is positive for real objects, okay? And do is negative for virtual objects. So this is a real object. So the do for this will be positive, will always be positive. And if you have a virtual object, say like you have like a picture of this on the computer, then that will always be negative. Okay? The di is positive for real images, and the di is negative for virtual images too. Okay? And F is always positive for concave mirrors, and F is always negative for convex mirrors. So make sure you write these down. I should have told you that before, but make sure you write these down. Okay? And there are more equations that can go with this. There's one more, and it's the magnification one to find the height of your image. And it is M equals negative di over do. Okay, let me repeat that. M equals negative di over do. That will help you find the magnification or the height of your image. I'm going to keep clapping during this whole video when I get to a new section. And this section is called lenses. So, like, as you know, I was going to do them separately because, of course, I'm not going to explain both mirrors and lenses in 5 minutes. So, 5 minutes for each. So, let me get my notes. My notes. So, a lens, or lenses if you want to get plural with it, is a transparent material like plastic or glass, and it has to have 2 faces to it, and they refract light instead of reflect. So refract means that the light still goes through it, but it goes through it different than when it came. Like, it goes out of it more different than it came into it. So the 2 faces is a part of a sphere, and they can be concave, convex, or even flat for the matter. And an example of that is like, where's my example? Like, this is my example of magnifying glass, and it actually has a convex lens because the middle is actually thicker than the sides. And you know, when light travels through this, the sight around it, like when light rays travel through it, the light rays actually combine together to make a bigger image. See my image? That's my example. And there's different types of lenses, as I named before: concave, convex, and flat. I really only gonna name 2 of them, so concave and convex. And convex lenses are thicker in the middle than they are at the edges, okay? So these lenses, convex lenses, are called convergent lenses because when light travels through, the lights always come together. So remember, convex lenses is literally the same thing as convergent lenses. Okay? Put that in your dictionary. And put this in your dictionary too, because concave lenses is the exact opposite of that. See, their center is thinner than their edges. And when you put light through that, when light rays go through that, it actually spreads it more out when it goes out. So, for one, remember this: concave lenses are the exact opposite of convex lenses. Okay, they do the same thing, but in totally opposite ways. And a concave lens is called a divergent lens, okay? Divergent equals concave lenses, okay? So and there are different equations for these. Like, there's one of the equations you use for both lenses and mirrors, and that one of the equations is the base equation: 1 over F equals 1 over DI plus 1 over DO. Like, that's the universal equation for mirrors lenses. It goes for both equations. And one other equation is used for magnification. Now, if you remember back in mirrors, magnification is used to find the height of the image, okay? The height of the image that traveled through, that the light traveled through, okay? Remember this, kids, because the battery is about to die. F is positive for convex lenses, okay? F is negative for concave lenses. DO is positive on the object side of the lens. DI is positive on the other side, the image side of the lens, as long as the images are real. DI is negative on the object side of the lens where images are virtual, okay? So DI is negative on the object side of the lens where the images are virtual or not real. Remember that. Now let's review. So we went over mirrors and how they work and where they came from and what equation to use, and we also went over lenses and where they came from and like examples and what equations to use. And those equations were right here. All the equations. That was the review of it. And I just skinned it up, like, you know, take my word for it, but also don't take my word for it. Like, if you need more info, ask your teachers. You know, there's help around you. Somebody is bound to help you. Just like an interview and just an informational video about what you have to expect in the chapter. So, with that being said, I'm going to end this video right now. So, peace out. And also to remember to like and subscribe. Like, you don't have to like or subscribe if you don't want to, but I would really appreciate it. It will help my channel grow as a newing channel. And please give me some feedback and some ideas about what more videos I could make. So, like, I appreciate that. Okay, now this is the real ending.